Hello everyone, today we're talking about ellipses, section 9.2 in our book. So you're going to want to make sure you get the information down. It's in the PowerPoint that accompanies the video, whether it's a horizontal or a vertical ellipse. So you're going to see our general form is x squared over a squared plus y squared over b squared equal to 1. And how you know if it's a horizontal versus a vertical is if the larger number, the larger denominator, is under our x, then it's horizontal. If our larger number is under our y, then it's vertical. So that's how you know the difference between a vertical and a horizontal ellipse. So let's go ahead and find the vertices, foci, eccentricity, determine the length of the major and minor axes. I'll explain what those are when we get there, and then sketch the graph. So the first thing we have to do is we have to get it in standard form, where the right-hand side of our equation is just 1. So I've got to go through and divide all of our terms by 30, so I get a 1 on the right-hand side of my equation. So I get x squared over 6 plus y squared over 5 equals 1. Okay, so now already I can tell this is going to be a horizontal ellipse because the denominator under my x squared is larger. So now let's go ahead and find the vertices, foci, and eccentricity. So to find the vertices, right, so the vertices, which are the points on either side of our ellipse, are going to be plus or minus a, and the minor vertices, so the thinner part of our graph, are going to be plus or minus b. So we're going to have to find a, right? And since a squared, right? I know this is a squared because it's the larger number, always is my a, is equal to 6. A is equal to square root 6. And I know my b squared equals 5, so I know b is equal to square root 5. So I've got my a and b. Those gives me my major and minor vertices. So that means my major vertices are the points radical 6, 0, and negative radical 6, 0. And then my minor vertices, I do it with a prime, so it means vertice prime. Our second minor vertices, that will be 0, radical 5, and 0, negative radical 5. So when we go ahead and graph them, we're going to need to know those points, those pieces of information in order to sketch the graph. All right, let's keep going. The foci. So the foci are always equal to our value c, and many of the times they won't give you your value c. You're going to have to solve for c knowing a and b. And if you see in our ellipses, when we're looking for the foci, c squared is equal to a squared minus b squared. So you'll notice the equation has a plus, so when we're looking for the foci, that equation has a minus. So if I go ahead and solve for my foci, I get c squared is equal to a squared minus b squared. Okay, so c squared is equal to a squared is radical 6 squared, so just 6. B squared is 5, so I get c squared equal to 1. So c is equal to 1. So now I found my major minor vertices, I found my foci. The last thing I need to find is my eccentricity. And eccentricity is basically just how curved is my ellipse. And in terms of sketching, it's not really going to help us sketch in any way. But eccentricity is definitely a critical piece of information that you'll be looking for on the test. So eccentricity is just your point C, your foci divided by A. And since my foci is 1, I get 1 over radical 6, which is radical 6 over 6. That's my eccentricity. That's just how curved my ellipse is. So now we have all the information we need to go ahead and sketch our graph. So I'll draw my axes. Our ellipses, just like our parabolas, are going to be centered at the origin, so we're not worried about shifting them one way or the other. And so let's see. My A is at, and they call the major vertices A, so my A is at negative radical 6, 0. And my other major vertex is at radical 6, 0. Okay, and then my minor vertices, so we can call this A or major vertices. And my minor vertices are B, they call them B, or right, I did V prime, whichever one you want to do. And those coordinates are 0, radical 5. Don't know why that went orange. And again down here, 0, negative radical 5. So just like with our parabola, we're going to need to just label those points so I know that you know how your sketch is looking. And I approximated these, so on a grid, let's see, I approximated radical 6 is like 2.4 or something like that, so I can see that A is, you know, a little bit more than 2, and radical 5 is like 2.1, so it's much closer to 2. Okay, so something like that. You can put your scale just like that. And then we also need to graph our foci. So those are at plus or minus 1. And those are our foci. They call those, well, yeah, C. So negative C and C. Okay, and this was negative A and negative B, or negative B minor, so minor axis. So then I can go ahead and draw my ellipse. So my actual ellipse is going to look something like that. Not perfect, but I'm not asking you to draw it perfect. As long as you have your points labeled, we got our ellipse sketched. Next, find an equation for the ellipse whose graph is shown. So they've given us this ellipse here. We need to go ahead and determine the graph from there. So if I take a quick look at this point, right, so they're telling me that this is at the point 0, 2. So I know that that is either my A or B, right, depending on whether or not it's the major or the minor. But I know that it's got to be my minor because this is y equals 2. So we can see that the y is going to be a little bit larger than 2. So I know that my A has to be under my y. So when I plug it into the general form, I'm going to put x squared over b squared, because I know that my y value is just a little bit larger than my x value. Okay, because the largest x value is 2, the largest y value is going to be more than 2. We don't know exactly what it is, but we can definitely see it's going to be more than 2. So if I go ahead and plug in for what I know, I know my x value for this point is negative 1. I know my y value is 2. I don't know my, actually I do know my b is 2. And I don't know my a. Right, I don't know how high this goes up on my major axis. So I'm going to go ahead and solve for a, and then I'll be able to plug it back in and find my equation for this circle. So if I keep on going and I solve for a, let's see, I get 1 squared 1/4, 4 over a squared. Go ahead and subtract 1/4 to the other side, so I get 4 over a squared equals 3/4. And then I'm going to take and switch the 3/4 into a squared because I can do that. So that gives me 4 divided by 3/4 equals a squared. And when you do that division, we get 4 times 4/3. So I get 16 over 3 equals a squared. Now I can go ahead and solve for a if I wanted. And in fact, if I solve for a, so a equals square root 16 over 3. And so when I do that, just to give you an idea of how far that goes up the major axis, that goes up to 2.31. So if we look at our picture, just like I was saying before, this point is really 2.31. That's how I know that this is a vertical ellipse, not a horizontal ellipse. It looks pretty circular, but it actually goes up 0.3 higher than it does wide. And so my final equation, I plug in for a squared. So my final equation is x squared over 4, right? Because I had 2 squared when I plugged in here, when I plugged in 2 squared, when I plugged in b squared, and this is not equals, this is a plus, y squared over, and this is 16 over 3 equals 1. And we don't want to have a fraction in the denominator, so let's go ahead and just solve that. So y squared times 3 over 16 means my actual equation is going to look like x squared over 4 plus 3y squared over 16 equals 1. So we found our equation of this ellipse given the point and 1 point on its minor axis. Next, find the equation for the ellipse that satisfied these conditions. So they told us our foci are on the points 0 plus or minus 2, and the minor axis is length 6. So I just remembered I forgot to talk about minor axis on this problem. So all that means is minor axis is the length from my minor vertex to the other minor vertex. So here we can see the length of this minor vertex would be 2 times radical 5. So it's just double the distance from our origin to our minor vertex. Just like the same here, our major axis would be 2 times square root 6. So it's just the distance from one end of the ellipse to the other, whether we're talking about our major or our minor. So that's important to know going here. Okay, since my foci are on the y-axis, right, 0, 2 is going to be on the y-axis, I know that I'm going to have a vertical. So I know that my c equals 2, and since the length of my minor axis, right, so just a broad sketch. So here we have a really awful looking ellipse. But you can get the point that the length of my minor axis, if that's length 6, right, if the whole thing is length 6, that must mean that these points are on positive 3 and negative 3 on the x-axis. So that means my b value, so my c value comes from the foci, right? This is the foci are plus or minus c. The b comes from the fact that my minor axis is length 6, so that means each point is 3 units away from the origin. And then we can go ahead and find my a using the c squared equation, and then plug it back into the general equation to find this exact equation. So if I go ahead and solve for a, I get c squared equals a squared minus b squared. So I get 4 equals a squared minus 9. So if I add the 9 to the other side, I get a squared equals 13. I don't need to go ahead and solve for just a because I'm looking for a squared in the general form. So if I have my general form, I have x squared over b squared, right? B squared under the x in this one because I know it's a vertical ellipse. then I got y squared over a squared equals 1. And so I plug in for my b squared and my a squared, I get x squared over, and my b was 3. And my a squared was 13, so I don't need to square that. I already have my a squared is equal to 13. So my final answer should be x squared over 9 plus y squared over 13 equals 1. Alright, that's all the examples I have for us. So go ahead and try the example problems that accompany this in the PowerPoint. Like normal, I've been giving you the answers at the end, so hopefully you can check your work with the answers and we can be all on the same page when we go over it next class.